All right, so far in this chapter, we've looked at a few different types of graphs. We've talked about bar graphs, we've talked about histograms, and today we're going to look at another type of graph. Now, this one's called a box plot. Now, the nice thing about a box plot is it helps us illustrate and be able to interpret how the data are spread apart. So each of these different types of graphs have their own advantages and different uses, I would say. Now, in order to create a box plot, all you need to have is what's called the 5-number summary. Those are 5 numbers, and those are the only 5 numbers that we need to use to create this graph. So first off, the first important piece of this is called the minimum value, and that's pretty obvious. That's going to be the smallest number in a set, and if we skip to the last piece, the maximum then is going to be the largest number in a set. Now we have your Q1, your Q2, and your Q3. These are what we call our quartiles. We have our first quartile, our second quartile, and our third quartile. Let's start in the middle there. The second quartile is the median of all the data. Okay, now the key there is that it does include all the data. So that some people, will sometimes eliminate the minimum or maximum as part of the data when they try to find the median. No, you don't do that. You look at all of the data and find the middle number of that set. What that's going to do is that's going to create basically an upper bound and a lower bound, an upper part of your or lower part of your set and a higher upper part of your set. So the first quartile then would be the median of that lower half. The third quartile would be the median of the upper half. So let's look at the example here with this set of data. So let's say these are scores in an algebra test, and we want to find we want to create a box plot. So we're going to need to create the 5-number summary. Let's start with the easiest, and that would be finding the the minimum and the maximum values. And so the minimum value is at 61, and the maximum value there is 94. Now to find the median, remember now we could start eliminating crossing from the start and finish and work our way to the middle. Or remember what we've done is we said that we can count up how many items there are in the set, and there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So there's 14 numbers in the set. So if I take half of 14, I get 7. Remember, that's not where my median is. We're going to tack on a half. So that means my median is between the 7th and 8th number. So 1, 2, 3, 4, 5, 6, 7, 8. So the median is right here between these two numbers. Well, the number between 77 and 77, guess what, is going to be 77. So now what that does, what I like to do is when I find the median, no matter where that is, I like to put a line there. Now let's say if the median had been one of these numbers, a 77, we put a line there right on that number. And then we would find the middle of that lower set and the middle of the upper set. So we're going to do the same thing here. So if I find the middle of this lower set, that's going to give us our quartile 1. If I find the median of the upper set, it's going to be 83. So that's going to be our third quartile. So then when we have all those numbers, our 5-number summary, we're going to create our box plot. Now when we create a box plot, we use a number line. That's what's over here on the right. So I know that the smallest number is 61, my largest number is 94. Again, since I'm creating a number line, we just want to make sure that we can include those numbers in our scale. So I don't want to just start at 61. I want to start on the smallest number that would be near that. So let's start at 60 and go up to 95. And so what they did is they did that, and they counted by 5s for us. And so now let's look at how we create that box plot. So basically what you do is for every number, we graph those with a vertical lines of the 5-number summary. So we could see that our lowest number would be 61, and our Q1 was at 71, our Q2 was at 77, our Q3 was at 83. We just estimate where those would be, by the way. And our maximum is 94. Now what we do is we draw some lines. Now in the middle set of the data, so we connect the quartiles. So Q1, Q2, we connect the quartiles with the box. And then we draw lines. We call these whiskers. So sometimes they even call this a box and whisker plot. But we connect those from our ends of our boxes there to our maximum and minimum values. Now the way that we can interpret that is if we don't have that set of data, we can say that approximately 25% of our data is in that lower half, or the lower piece. And then we would have 25% in this section, 25% in this section, and 25% in this section. So our quartiles represent our middle 50%. Okay, so that box there represents the middle 50% of our data, approximately. So that's how we can interpret a box plot. Now we have another value here, and that's called the interquartile range. That's really important. So if you don't have my notes, that's something that you want to make sure that you write down that definition. And all it is the interquartile range takes your Q3, your third quartile value, and subtracts from it your Q1 value. That gives you the IQR. And again, that's where we find the middle 50% of the data. All right, I want you guys to look at this set of data. So I want you guys to find the 5 number summaries, so the minimum, the Q1, Q2, Q3, the maximum. I want you to find those on your own and draw a box plot. So when you create your box plot, just to be consistent here, so our plots will look similar, we're going to do the same thing as a previous one. So in your number line, we're going to count by 5s. And since my smallest number is 29, I'm going to start with 25. So if we count by 5s, I'd have 25, 30, 35, 40, 45. And we can end at, the largest number is 50, so we can just end at 50 there. So that's what your number line would look like. So I want you guys to go ahead and pause the video and hit play when you're ready to check to see if you've done it correctly. All right, let's see how you did here. So again, the 5 number summary, so we could easily find the minimum and maximum values are 29 and 50. So then if you count up the number of items we have in our set, you'd see that there's 10 numbers there. So half of 10 is 5. Tack on a half, you get 5 1/2. So it's going to be between the 5th and 6th term. So we see that it's going to be between 40 and 43 is where a Q2 would be. So if that happens, remember you find the average of those two numbers. So if we add 40 and 43 together, we would get 83. And half of 83 is 41.5. So that's our Q2. So if you ever have two middle numbers, you add those two up and divide by 2. So remember that divides our set into 2 sets of data, it divides our sets into a lower half and a upper half. Remember, we still include the minimum and maximum. Again, that is the one place where people make a mistake, is they cross out the minimum and the maximum for some reason and don't include those as part of the lower and upper set, which we do want to include. And so in that lower set, we would see the median there would be at 37, and the median of the upper set would be at 46. So that would be our Q1, our Q2, and our Q3. And when you create your box plot, that is what you get, what's there at the bottom there. So hopefully you guys got the same answers as I did. All right, so next we're going to talk about this concept of an outlier. Every once in a while you might have a set of data, and then you might have a number that's just way off the charts, either really big or really small, that might throw off the average. Like if you were to include that with your set, like let's say if we took a test, and it was just, I did not do a good job of teaching it, and everybody just really bombed the test, but then there's one student that just, for whatever reason, it just clicked for them and they aced it. Well, that one student might throw off the average. And so when I look at the average, it might be like, all right, people did pretty good, but then I look at individual scores and be like, oh my gosh, people didn't do as good as I thought. It's because that's sometimes, because an outlier will throw off that measure of center. And so we want a way to identify what those outliers are to determine whether or not we should include them as part of your measure of center. So here's an example where it has the payrolls of Major League Baseball teams on opening day of the year 2007, so a while back there. But you could probably guess where the Yankees would fall if you're familiar with baseball. They have a lot of money because of their all the money that the revenue they get from they're just based on their name and logo. So one team in particular has $190 million payroll as compared to other teams. And so we want to figure out, is that an outlier? Is the other bar or the other number there that's also pretty high, is that also an outlier? I don't know. So the way that we find an outlier is what we call this 1.5 times IQR criterion. Okay, now I don't like the word criterion just because it's not a word we use that often. The criterion is just a rule. So you can think of this as a 1.5 times IQR rule or method or trick. Whatever word you want to use, it's just going to be 1.5 times IQR. 1.5 times the IQR is going to give us like a measuring stick. And what we're going to do is we're going to put that measuring stick after so it's 1.5 times the interquartile range. So we're going to put that measuring stick after the third quartile and before the first quartile, and anything above or below that value would be an outlier. So we could take Q3 plus the 1.5 times IQR, and anything bigger than that would be a outlier on the far end. Now here's where it gets tricky. If I'm going to put it to the left of the Q1, I'm going to subtract that measuring stick, the 1.5 times IQR, whatever that value was. I'm going to subtract that from Q1, and anything smaller than that would also be an outlier. All right, so let's look at, we already have a 5-number summary for the, so they gave us a 5-number summary for that payroll information up above there. We want to use that 1.5 times IQR method to determine if there are any outliers. So let's first do this. Let's figure out what the interquartile range is, the IQR. Remember, that's what that represents. That's a Q3 minus the Q1. So if I take the Q3, which would be 100, minus the Q1 of 62, I get an IQR of 38. Now we want to use the 1.5 times the IQR method. So I want to figure out what's that measuring stick, what's that tool, what's that number I'm going to use as my measuring stick is what I keep referring to it as. So if I take 1.5 times the IQR, if I take 1.5 times 38, we get a value of 57. So what I'm going to do is I'm going to take that 57 and I'm going to tack it onto the Q3. So if I take 100 plus 57, I get 157. So if there's any values bigger than 157, that would be an outlier. So if I look at my list, we have 190. The next smallest is 143. So 190 is an outlier, but 143 is not. So now I want to see if there's any outliers on the low end. So this is where, like I said, it gets tricky. You're going to take your Q1, which is 62, and subtract 57. So anything smaller than that would be an outlier. If I take 62 minus 57, I get 5. Well, there's no teams that make less than, that have a payroll of less than $5 million. So the only outlier is the 190 million. Okay. So if we were to graph this one on using a histogram, using a bar graph, we would have, we would use 143. So if we were to do this, our box might look something like this. With this at 143 and then 190, we would have a dot. Okay, so we represent an outlier with a dot. And then what we do is use a new, so your maximum is still 190. We would not change that at all. But when we represent it with a box plot, we would put this whisker at the next largest number. All right. I want you to go back, and I'll scroll back here in a second so you can look at the data. But I want you to go back and look at the data in example 1 and use that 1.5 times the IQR method to determine if there's any outliers. Let's look back at example 1. That's this data right here. So we have our 5-number summary. So we have our Q3 and our Q1 are right there. So I want you to use that information and the numbers in this set to find out if there's any outliers in that data. So go ahead, pause the video, and hit play when you're ready to check to see if you've done it correctly. All right, so hopefully you found that there are no outliers for this set of data. The way that you do that, again, is the IQR would be 9, because 46 minus 37 would be 9. And 1.5 times IQR would be 13.5. 1.5 times 9 is 13.5. So we're going to use that 13.5 as a measuring stick. So we would take the Q3, which is 46, and add it to 13.5, and you get 49.5. And there were no scores larger than 59.5. And then we would take 37 minus 13.5. When you do that, you get 23.5. And there were no scores in the test that were smaller than 23.5. So there were no outliers in that data. So sometimes, obviously, that's going to happen. All right, I want you guys to end this activity, this lesson, by looking at trying to match these histograms with the box plot that would best fit that data. So without actually knowing any of the numbers, so I want you to match the histogram to the appropriate box plot. Because remember, a histogram and a box plot are both kind of showing us how data is spread apart. But the box plot does it a little bit better visually as far as that's concerned. All right, so I want you to pause the video and go ahead and match up each of these graphs. All right, let's look to see how you did. So histogram A, we can see that we have this outlier way out here on the far right. And so when I look at those, the only bar graph that, or the only box plot rather, that has an outlier in the far right would be this one. And actually, according to this box plot, it shows that some of that data would be outliers as well. All right, let's look at the other two. So the other two do not have any outliers based on the box plots. Now, histogram C, that looks more symmetrical, more that the data is kind of spread out evenly between all the values. You can see that here there's a little bit of anomaly, a little bit bigger there. But graph C, the histogram is more evenly spread out, so that's going to be box plot 1. And histogram B, we can see that it's skewed left. Remember the way that just because the data is pushed to the right means the tail is going to the left. So if we're going to describe histogram B, we would say that it's skewed with the tail to the left. And that is what this box plot is showing us, is that there's a lot of data scrunched up between here. They're not really spread out here, but they're more spread out down here on this low end. And that's what's happening with histogram B. So that's the connection there between histograms and box plots. So hopefully this lesson made sense to you. And if not, again, make sure that you come to class tomorrow with any questions that you have from these notes.